Okay, this is the fourth revision video for P1 and we're going to have a look at ways in which we can generate electricity. So first thing you need to remember, there's some keywords on here to recall. We start with an energy source which can either be fossil fuels which we burn, so coal, oil, etc. It could be nuclear fuels, it could be uranium, plutonium, in which case it's nuclear fission which releases the energy. Or we could use a biofuel, so a fuel from a living material, and we'd burn it. Okay, so we'd burn both of those two, or this one is nuclear fission, okay, which you'll be familiar with from P2. So we heat that energy source, if it's one of these two, and that will heat water, which will create steam. Steam will turn the turbine. That will go straight into a generator, and the generator will produce electricity. So you need to be able to remember, particularly turbine and generator are really important key terms to remember, but also think about the change in energy as we go through, because as we know, we can't waste, we can't create or destroy energy. It has to be converted into a different form. So here we've got it in chemical energy, okay, in either of these. That's being converted into heat energy, okay, here, then kinetic energy, turn that turbine, and then electrical energy into the electricity by the generator. So just worth noting that as well in terms of forms of energy, just so you're thinking about that for your exam. If we then look at renewable forms of energy, okay, because this one over here we're talking about non-renewable for the fossil fuels, we can think about other types of turbines, so water and wind used to drive turbines. There's obviously positives and negatives to this. Not always windy, okay, so that's when we wouldn't generate electricity. So it's not reliable as such, because we can't predict when it's going to be windy. Water we obviously normally we need to be running or tidal in some way to flow to be able to produce that movement of the turbine and therefore electricity. And because obviously we need wind to do the wind turbine, we tend to see them offshore, so out at sea, and because it's slightly more windy there. We can obviously also produce electricity from the sun's radiation with solar panels, and that can either be electricity or, like we've seen before, we can use it to heat water. Okay, so there's a couple of things there in terms of how we can use the sun's energy. We've also got geothermal energy, one that tends to be forgotten by most people as well, in terms of one we're not probably familiar with particularly, but in volcanic areas, hence my drawing of a volcano, what we can see here is we get steam and hot water coming up from underground, and that can come into some sort of power station, and that again can be used to drive turbines. So this is an idea of heat being converted into kinetic energy, and that will be connected to a generator just like over here, and then it will generate the electricity for us. So they're all quite large scale in terms of building together, and you can obviously have a small wind turbine on your land, that would be small scale, but you may find hydroelectricity as well featured on small scale production. And small scale production is really helpful for if you lived in a remote area where you can't access the national grid, which we'll talk about in a second, or roadside signs. You might have seen even a small little turbine attached to those just to give it enough energy to be able to turn it into electrical energy so it can move the sign. Hydroelectricity then is where you have a dam, so a large body of water placed behind a dam wall, and then when you need it, you can then release that water and it can flow down the hill, turn the turbine, and again that turbine will be connected to a generator as over here, and that will generate electricity. Okay, so it's the same principle really here that applies to these here as well. This is really helpful because you can completely predict what's going to happen. So obviously you need your water behind here, but then if you suddenly needed a large surge of energy, because you had a demand for the electricity, then you could release that water and generate electricity really quite quickly. It's not useful for just everyday, sort of what we call base load, but it's really helpful for a boost if we needed energy really, really quickly. Okay. However, there are negatives to these. They do have an impact on the environment, and you have to think obviously in each case what that impact will be. But some of them will release substances into the atmosphere, for example carbon dioxide, which we know leads to global warming. They will produce some sort of waste, particularly over here with fission, that's nuclear waste, so we've got to deal with that as well. Noise and visual pollution. Please on your exams don't write the word just pollution. Please clarify what sort of pollution you're talking about, because pollution on its own rarely gets a mark. And obviously destruction of wildlife habitats, so we've got loss of animals, so reducing that biodiversity seen in that area. The other thing it does say as a side note for you to be aware of is something called carbon capture and storage, and I have seen it feature on exam papers of late, just as a new technology, but technology which is advancing very quickly. Basically what it does is what it says, carbon capture, so it captures the carbon and it stores it. So it prevents carbon dioxide, which might be released into the atmosphere by one of these, so particularly burning fossil fuels, and it stops it building from the atmosphere. An example would be the oil and gas fields under the North Sea, which captures that carbon dioxide and locks it away, so it doesn't go into the atmosphere and it doesn't cause global warming. But I don't think that we have to talk a huge amount on it, but just be aware of what it means and what it's all about and how it's going to be beneficial. Right, and then finally, the national grid. A national grid is made up of your transformers, your cables to take it across the country or within that area into the house. Now, associated with this, you've got step-up transformers and step-down transformers, and you need to be aware of what these do. So a step-up transformer you'll have prior, okay, as it's leaving the power station. So effectively, this bit here has where that ends, this starts. So you get your generator, you get electricity, comes down through the wires or the cables, and it comes into a step-up transformer. The reason being is what it does, it steps up the voltage, it increases the voltage and it decreases the current. The current is the flow of those electrons travelling through those cables, and the more we have of them, the more they'll rub against if you imagine sort of the inside of that cable, and you'll lose the energy through heat, okay, through friction, build up in heat, and the energy is lost. So if we step it up and we lose the current, drop the current down, so we've got a little bit less flowing through, but increase the voltage, the amount of energy being carried, then we can reduce the amount of energy lost as heat. It would be a real waste if we produced all this electricity and then we lost it as heat all through these cables. So importantly, at the start of this sort of national grid structure, we have an increase in voltage, a decrease in current, and therefore we have less energy lost because of the step-up transformer. If we just let that flow through, we'd have a very, very dangerously high voltage coming into our houses, which would be, an incredible amount of damage. Should we get an electric shock or something like that? So for safety, we have to have a step-down transformer, and that basically takes the voltage travelling down through the cables and it brings it down to a safe amount, but one that's still strong enough to work the electrical appliances within the house, but not too dangerous. So it drops it down to 230 volts, and it just decreases the voltage, and increases the current. Okay, so that's what step down transformer does, and that's linked in with a national grid. Okay, so you need to be aware of that. So step up transformer going in increases the voltage, and step down transformer reduces the voltage before going into the home. Okay, so nice simple topic, I think, really. Things you're probably quite familiar with in terms of non-renewable, the route through the power station to get electricity, the renewable forms of energy, the effects on the environment. We've mentioned carbon capture and storage, and then the national grid and the role of the step-up transformer and the step-down transformer in terms of reducing the amount of energy lost through heat, through the cables, and then obviously reducing it to be safe for the homes. All right, so that's the end of the 4th revision video for P1.